Good afternoon, everyone. We have our webinar on bioenergy and co-digestion webinar. This is hosted by PNCWA, Sustainability and Biosolids Committee. So our agenda for today is we'll start out with Riley. He'll talk to the what and the why of organics diversion. And then we'll have our next speaker will be Josh Newman, and he'll be discussing proposed renewable fuel standard set rule and other changes, followed by Bryan, and he'll be discussing integrated bioenergy recovery and biosolids planning. And then we'll get into renewable natural gas to natural gas pipeline. That will be Mark with MWMC. And then we'll have Derya close it out, discussing technologies, processes for pretreatment and management of source separated organics. And then what we'll do is we're going to hold questions to the end. We have a lot of material to get through. So we'll hold that for the last 15 minutes. So the learning objectives here is just to provide an overview of the trends of the organic diversion regulations, impacts and opportunities for utilities, and then discuss planning for accepting source separated organics, and then trends and barriers recovering energy and resources from source separated organics. And then we'll have a cost benefit model case study. So these are the learning objectives of this webinar. And then CEUs and PDHs for attendees will be provided. There will be a survey at the end of the webinar. And then if you're requiring CEUs, please have your wastewater certification number available. And then Marie, just on that survey, you can end the webinar, but there will be a browser that opens up for them to fill out the survey.
That's right. So as soon as you leave the Zoom call, you should look at your internet browser and there'll be a page that says, thanks you for joining. And there'll be a quick survey. So if you need CEUs or PDHs, that's where you can enter your information. And you can always send any questions about that to me. I'll put my information in the chat. But any questions on that can come to me, but just keep your eye out for that survey at the end.
Okay, great. Thanks, Marie. So I'm going to stop sharing. And then we're going to turn it over to our first speaker, Riley. Riley's he's a principal engineer with Hazen and Sawyer out of the Portland, Oregon office. He has a BS from the University of Nevada, Reno, and an MS from Oregon State University. As a professional engineer, he's worked on the planning, design, and construction of water resource recovery facilities throughout the Western United States.
Perfect. Anthony, Marie, can you see my screen and hear me okay?
Yes.
Good. Well, good afternoon, everyone. As Anthony said, I'm Riley Mernan. I'm with Hazen and Sawyer here in the Portland office. And thank you for PNCWA and the Sustainability and Biosolids Committee for setting this up. Today, I'll be just doing a brief intro to what we're going to talk about, and that's about organic waste and diversion. And this presentation will be all about the what and the why. So we'll define what organic waste is. We'll separate from the municipal waste that we're really concerned about versus other types of organic waste, and then talk about why we feel the need to be putting this separate into this. So first off, what's an organic waste? It's any solid waste containing material from living organisms that could be degraded. So food, green material, landscaping, textiles, wood, pulp, paper, manure, especially relevant to us, biosolids and sludges. This pie chart gives a representative breakdown of a typical solid municipal waste stream. So of the waste coming out of a local municipality, about 67% of it is organic and 33% non-organic. So breaking that down, we have wood waste, very relevant in the Northwest. So that could be facility byproduct or construction leftovers. Paper and cardboard, relevant throughout the United States. Biosolids is the big one. I think that we can really influence and have our hands on, as well as food materials. So you start to see a lot of around the country, start to see push for high strength waste receiving at wastewater plants. And then green waste as well. Anyone who's driven through the rural Northwest has seen the burn piles, and what's the focus on that for the rural side of it versus the urban side of it. Breaking that down further, what industries do these organic wastes come from? You start with agricultural wastes, harvest residues, animal manures, food processing. On the coastal region of the Pacific Northwest, where you have a lot of seafood processing plants and fisheries. You can talk about slaughterhouse waste. There's plenty of breweries in the Northwest. You have spent grains from that production, as well as cannery waste. Industrial waste, pulp and paper, gelatin starch, pulp and paper more relevant to the Northwest. But where we really want to focus on this webinar today is municipal organics. So that's residential, what goes in your bins when you take them out, commercial, what's coming from mainly restaurants or other commercial sources, sewage sludge, the one that's closest to probably most of us, as well as biosolids and fog, which is fats, oils, and greases. We'll talk about fog as a whole on this webinar. So why do we want to divert organics from landfills? Well, the greenhouse gas emissions from methane as they decompose is 28 times more powerful than CO2 over a 100-year period, and 84 times more powerful than CO2 over a 20-year period. In some places, there's a lot of landfill space. Some places there's not. So not just from a climate change point of view, but also from a volume point of view, you can increase the life of a landfill by reducing the volume sent to it. And this is something that's becoming more relevant. Is typically we operate on a linear economy where raw materials are extracted, a product is produced, and then it is dumped into a landfill. But as we see with this one water push out west, we're looking more for a circular economy: reduce, reuse, and recover. And then we'll talk a little bit about how there are regulatory pushes to make this practice actually occur and not just a theory. Looking at the methane emissions by source in the US from 2019, the little piece of the pie that's jutting out there is where we can really have an impact, and that's municipal solid waste landfills. It represents about 15% of the US methane emissions. So why do we care? In the Northwest, we're all very, very common with drought. Us and the West Coast as a whole has had a wetter year, but that certainly has been the pattern over the last few decades. Oregon especially has had trouble with drought. Reduced snowpack as temperature rise. Snowpack is great because it acts as a reservoir. As that snow melt is timed, it helps our receiving waters, and our source waters. But as those patterns change, our ability to provide clean water for our communities needs to adjust. And the methane from these organic decomposition has a big impact on climate change. Wildfires, so these charts go up to 2018, but as we know, past 2018, the trend has definitely not gotten better. Idaho and Oregon and Washington have all had some pretty severe wildfires. And going back to the circular economy over a linear economy can help out with those effects. You have coastal erosion. I think this is really relevant this year with the atmospheric rivers that have been hitting the United States. San Francisco, they had areas where they had 500-year storm events. Fort Lauderdale 2 weeks ago had a 1,000-year storm event. So, with the effects of climate change, we don't know how much our statistical storms are still statistical. And that's another driver for why we want to do this and divert organics from landfills. Heat waves. As many of you know, a couple of years ago, Oregon in the summer had a big heat bubble, and where it reached, the mid 115-degree range. That was the largest mass casualty event in the state of Oregon. Was just the heat wave from that weekend. So just another reason to care about organic diversion. So what about regulation? I'll talk very briefly on this. This will be touched on later in the webinar. As you can see, there are cities and states, metro areas around the country that have started to enact policy as well as actual regulation. So that is, policy is guidelines, regulation is enforceable. So it is coming. It is coming in larger metro areas. The Northwest, certainly well represented nationwide on caring about organic diversion. That's something that I think we can all be proud of. But the rules are going to be specific to each state and metro region, and navigating those rules and coordinating with wastewater treatment plants for biosolids is going to be really important and a big part of all our careers as we go forward. And to the why. So to summarize the why of why we want to do this, we want to divert waste from landfills with this methane that we can have control over production and capture of. We can generate renewable energy on site locally with, potentially massive cost savings. While we comply with policy, we help out the buffering with population growth, and we reduce greenhouse gas emissions. It creates good green jobs. It keeps the circular economy is also more of a local economy, so it retains more money within the local economy, and it reduces fats, oils, and greases and food waste in the collection system, which we know can create quite a tax on collection system budgets. This biosolids is commonly used as fertilizer in the agricultural Northwest. That's a great resource to have, and it helps increase regional sustainability. When you see utilities being concerned about biosolids management, the conversation of a regional facility where many local facilities all team up together is typically talked about. So it helps strengthen, local cooperation. So thank you. That was the why and the how, and the what and the why, and we'll move on to bigger expansions on those topics I talked about.
Thank you, Riley. So our next topic will be proposed renewable fuel standards set rule and other changes. And that presenter will be Josh. Josh is a biogas utilization program manager with the City of Portland, Bureau of Environmental Services. He's an environmental engineer, has over 30 years of experience in the wastewater field, working both in the public and private sectors. Over the last decade, Josh is focused on biogas utilization, and he's currently the program manager for BES, biogas utilization. Josh? Josh, I think you might be muted. Josh? Maury, is Josh muted?
He is. I'm requesting him to unmute, but
Okay.
just a minute.
Sure. If Josh is having issues, maybe we can jump on to Bryan, Murray.
Sure, no problem.
Okay.
Yeah.
So we'll get back to Josh. So our next topic will be integrated bioenergy recovery and biosolids planning. The speaker for that will be Bryan Lisk. He's Hazen and Sawyer's National Energy Management Service leader with 25 years of energy management and design experience in water and wastewater field. Bryan is involved in many aspects of energy management, including energy strategic planning, energy program development, bioenergy recovery, energy data management and visualization. Bryan specializes in renewable and non-renewable on-site generation systems, bioenergy recovery systems, energy procurement services, and power distribution systems. Bryan is also a certified energy engineer by the Association of Energy Engineers. Bryan?
All right, thanks. Thank you very much. First off, I want to make sure I want to do a sound check, make sure everybody can hear me and see my screen.
Check. You're good,
Just give me a
Bryan.
little thumbs up
Okay.
there. Okay. All right. Well, thank you very much, and good afternoon, everybody. I'm Bryan Lisk. As Anthony said, I'm Hazen and Sawyer's Energy Management Services Lead, and I'm going to talk about integrated bioenergy recovery and biosolids planning. And I think there's a industry-wide recognition that there's a very strong and somewhat complex relationship between bioenergy recovery and biosolids, and it really makes sense that they are looked at together and holistically. So I'm going to talk specifically about this relationship, and just a quick agenda. Going to talk a little bit about the bioenergy recovery overview and some of the trends that we're seeing. Talk about the objectives and challenges with integrated bioenergy recovery and biosolids planning. Talk about a couple of the keys to performing a comprehensive bioenergy recovery and biosolids plan. And then we're going to go over a case study just to demonstrate this relationship between bioenergy and biosolids, just to give everybody a feel for that. So big picture, one of the trends that we're seeing is that the demand for bioenergy recovery is definitely growing nationwide. Bioenergy recovery does a lot of good things for us. It is a renewable energy source. It addresses climate change, increases our national energy security, and we're seeing a lot of new energy pathways and energy markets open to promote the utilization and monetization of bioenergy. So from a national level, we're seeing a lot of things promoting it from the producers. Historically, it's been really focused on revenue and funding, but however, we're seeing that mindset change quite a bit. The revenue part is becoming less and less of a driver, and we're seeing just maintaining a culture of sustainability become the dominating driver for moving forward with bioenergy projects. So that's definitely good to see from an industry-wide perspective. When we think about bioenergy recovery, we typically think about biogas or digester gas because about 99% of all the bioenergy recovery projects do involve anaerobic digesters and digester gas. And the typical technologies that we see to recover energy, combined heat and power, it does exactly what the title says. We produce a combination of electric energy and thermal energy that can be recovered to offset heat demands. We also have thermal systems to produce heat from biogas, and this is for either sludge drying, digester heating, building heating, whatever thermal needs are needed. There has been a lot of interest in growing recently about renewable fuels, specifically renewable natural gas. This is a bit different in that it's not a combustion process and it's not combusted on site. This is a conversion process where we take raw digester gas, filter out everything but the methane. So at the end of the day, it's chemically the same as natural gas. And it can be sold into different markets, specifically the transportation market that I'm going to talk about a little bit, but Josh is definitely going to talk a lot about this. And we could also flare the gas, which nobody really wants to do because we're not making any type of beneficial use. But there are a lot of technologies that are evolving. Some of them are more established. Some of them are in their embryonic phase that we just call them non-digester bioenergy recovery technologies. Pyrolysis and gasification. This is gaining some traction, even though we don't have many installations in the US right now, but as a way to extract energy from biosolids while also addressing the PFAS issue and also lowering overall hauling costs. Direct combustion of biosolids. This is basically incineration. This is something that's been around quite a bit. Does produce a lot of heat that can be recovered, but it also addresses the PFAS destruction issue and generates gas, and it really does do a good job of lowering the overall biosolids hauling costs. Hydrothermal liquefaction. This is actually a process where we're doing a direct conversion of biosolids and the organics and biosolids into a crude oil material that can be further refined for renewable fuels. And there's other technologies that are starting to gain I guess, some interest, supercritical water oxidation. I don't know a lot about this technology, but I do know that, under the right pressure and temperature conditions, we can really break down all of the organics, basically down into their elemental components and recover those as resources, while at the same time also generating thermal and other energy and actually producing electric energy at a certain size. This can actually become a net energy producer, and it does also address the PFAS issue that everybody's talking about right now. So one of the biggest trends that we're seeing right now is that there's a lot of development in different energy markets and pathways to those markets. You look at the transformation of biosolids into energy. We start off with a bioenergy resource, whether it's biogas, organic matter, even nutrients. It's got to go through some type of transformation into a marketable energy source, whether it be electricity, thermal energy, renewable natural gas, or other fuels. But in general, we have to have some pathway into a market, a physical pathway. This can be an electrical connection, it can be a pipeline, it could be a hauled product. Historically, thermal energy and electric energy has been used to basically offset your purchased energy. So in a sense, you are your own customer. But there's a lot of other markets that are opening up and pathways to those markets. And Josh is after me is going to talk specifically about some developments in the transportation sector. But bioenergy can also be sold as a transportation fuel, which qualifies for pretty valuable commodities known as RINs. And since we do have the proliferation of electric vehicles, we can also sell electricity as a transportation fuel, and that commodity is called an E-RIN. But this is a good example of a mandated market. We're also seeing voluntary markets open up for biofuels and biogas. Energy utilities and also blue chip corporations are not, some of which are not under any mandates to purchase renewable energy or are purchasing renewable energy voluntarily from producers such as wastewater treatment plants just to satisfy their own sustainability commitments. And in addition to a physical pathway, we also have to have a contractual pathway, which could be in the a power purchase agreement, offtake agreements, interconnection agreements as well. So. But this is encouraging because we have new ways to produce energy. We have new pathways and markets that we can participate in. But this also presents a challenge. That means that there's a lot more moving parts and a lot more variables now that we have to deal with when it comes to bioenergy and biosolids planning. So making informed and defensible decisions under what I will call under uncertain future conditions. And this includes, some of these pathways and markets. There is a bit of volatility in the energy markets. We also have evolving environmental regulations as well as energy and emission regulations, which really make this job kind of difficult because it's very difficult to predict where these markets and regulations are going. And on top of that, they're all changing at once. And, and actually navigating that is pretty difficult because they can all stack up in different combinations to support one strategy over another. So having the ability to navigate that complex situation is also presenting a challenge, and also managing risk. I mean, I think risk is one of those elements that's just not quite as recognized, or is not enough attention has been given to risk. But with energy, there is definitely levels of risk, not only market risk, but operational and financial risk that really have to be understood. So, one of the biggest trends that we are seeing is that just about every one of our either bioenergy projects or biosolids projects includes either an energy or biosolids component. So these two elements and these two studies are really coming together into one integrated bioenergy recovery and biosolids planning effort. And we're going to talk talk for the rest of the presentation, talk primarily about this planning effort. So the key goals of an integrated bioenergy recovery and biosolids plan really is just maximize the beneficial use of biosolids and also recover as much energy and resources as possible. By doing this, we increase overall sustainability, but we also have to do it in a way that we ensure regulatory compliance. And at the end of the day, really what this plan is supposed to do is really provide long-term guidance and implementation. And I use the word tool here. We don't think of a plan as a tool sometimes, but that's really what it's evolved into. And I'll talk a little bit more about that later. Another trend that we're seeing is that a lot of these biosolids and energy strategic plans are beginning with the energy recovery and biosolids beneficial use in mind. Historically, most biosolid master plans focused on the biosolids process, the regulatory requirements, and then that governed the energy recovery and the beneficial use strategies. We're seeing that reverse now. We're seeing the energy recovery and the beneficial use strategies play more of a leading role and actually somewhat dictating the biosolid strategies as well. So we're really starting with energy and biosolids use in mind here when we're approaching some of these projects. I think that's a pretty positive trend that we're seeing. So we have a number of keys to a real successful biosolids and energy plan. And the first one is to make sure that we account for the overall energy balance, mass balance, and financial balance. As I alluded to earlier, there are a lot of moving parts. There's a lot of different energy costs or energy markets that we can participate in. There's different bioenergy recovery strategies. The way that we manage biosolids is going to have a direct impact on how much energy and what type of energy that we produce. The regulatory issues, hauling costs, heat demands, energy billing rates, tipping fees. I mean, really the list goes on. And all of these can stack up in different combinations and in different ways to favor, one strategy over another, whether it be electricity production, heat recovery, sludge drying, renewable natural gas, chemicals, conversion and other products, and even nutrient recovery. So understanding, what are the conditions that would favor specific strategies is really a key part in accounting for the overall mass and financial balances. And energy balance is a key part of that. So this really is not an easy task because there are a lot of unknowns, as I said earlier. And so one way that we try to bring all these moving parts and pieces together is, and I think this is becoming more and more widely adopted, is what I call the roadmap approach. This is a good way to bring a lot of the known and unknown variables together. And I know this is probably very difficult for everybody to read, so don't try and read it, but I'll try to explain it to you. But what this is basically a visual representation of a biosolids and energy plan. And the way that this particular one is arranged is that we outline base courses of action with respect to biosolids and with respect to energy. And along that path, we identify certain events. Some events we know are going to happen at some point in time, like asset renewals. We're going to reach certain flows and loads, things like that. And when these events happen, we identify either certain projects to implement or certain events to address when that event happens. There's other events that we call if events that we don't know if they're going to happen or not. And this is mainly focused around market conditions, market stability, funding availability, regulatory changes. But this is a good way of bringing all of these different elements and moving parts together under a single visualization. And so that really kind of brings us to our second key here, is that these biosolid energy plans, these are not static plans. And the trigger-based roadmap is one way of making it a little bit more interactive and dynamic. But the plan really must be capable of evolving and changing, as conditions change and as projects progress forward. And I think that we all probably have a big, thick binder sitting on our shelf somewhere of some type of a master plan, which is a big stack of paper, which is very difficult to interact with on a day-to-day basis. And so we're seeing a trend where we're really moving away from this, I'm going to just call it paper-based deliverable, into something a lot more interactive and a lot more intuitive. And so, and this is just one example. This is a energy and mass and financial balance dashboard that we generated for one of our clients under for a biosolids and energy plan. But the technology is now here with Power BI and other similar platforms for us to produce these interactive deliverables, where everybody involved would have access to the energy and mass and financial balance. It's something that's we can make the use of sliders and variable inputs so that we can see how the overall mass and energy balance reacts to changing conditions. As conditions change and evolve, we can easily update them. And this is a much more engaging and much more immersive type of master plan deliverable that we think is going to really become the norm pretty soon. And so one of the last keys is to, and this really has to do with overall risk and trying to visualize the risk, but is to really evaluate over the long term, the range of outcomes for all the different, I want to call it alternatives. And this is just one way that we do it. There's a lot of different ways to do this. But as I said earlier, energy projects carry a lot of uncertainty, especially when it comes to the energy markets and the variability within those markets. In this example, we were looking at 3 different bioenergy recovery strategies: combined heat and power, biogas to drying, and also biogas to renewable natural gas. This particular client was out in the Midwest. Energy was very cheap. We had a very hard time making a good solid case for combined heat and power. For drying, again, this is the cumulative net revenue. We're able to actually get somewhat of a good revenue at very low capital at risk. But the renewable natural gas alternative actually provided at the end of 20 years the highest level of financial value, but also had the widest range of outcomes. And that's primarily because of the uncertainty and the variability in the RIN market. So this is just one example of how to visually represent risk. Looking at the range of markets, high and low growth scenarios, sensitivity to downtime, range of capital cost, and fats, oils, and grease, and high strength weights, co-digestion markets, and tipping fees and availability all kind of go into this. So I'd like to go over just a quick case study here just to kind of illustrate and show sort of a real world application of this relationship between biosolids and bioenergy recovery. And this is a case study that we did for the Goleta Sanitary District. This is actually, we started it back in 2019. And we called it specifically a biosolids and energy strategic plan. And the reason was because they wanted to address the biosolids need. They had digester rehabilitation and capacity needs, but one of their strategic objectives was to achieve plant-wide energy neutrality. This was very important to their board and to all their stakeholders. And they also wanted to diversify biosolids, sustainable use, outlets and market options, minimize exposure to regulatory and market uncertainty and risk, which that's a challenge within itself right there. So we started this project really looking at the energy and the end use parts first. And one of our first findings was that in order to achieve energy neutrality, they did not have firm capacity or they could not achieve energy neutrality without co-digesting fats, oils, and grease and high strength waste and other waste streams. But they also did not have the firm capacity to accept the amount of fog and high strength waste needed to achieve energy neutrality. So we had to look at options to increase their digester their biosolids capacity through either recuperative thickening or new digesters and some other options too. But eventually they decided just to add a new digester because that really provided them the best long-term value. So as we started looking closer to the energy parts, the other key finding was that we found that we were looking at the overall benefit from becoming energy neutral, and being energy neutral did not equal zero energy cost. In fact, if they achieved 100% energy neutrality, that only reduced our energy costs by about 65%. We did a lot of billing rate modeling with solar, with different billing rates, with different demand profiles, combining meters, just trying to figure out what's that best combination. But the way that their billing rate was structured, the way the net metering agreement was aggregated, and the surplus energy sellback, we really started seeing a diminishing financial returns after about 70% energy neutrality. So once this finding came to the surface, GSD decided, well, let's just focus on the best financial case alternative. Maybe let's back off on the energy neutrality objective. And this really did have sort of a ripple effect throughout the entire evaluation because it definitely impacted the value from fats, oils, and grease and high strength waste co-digestion. We also looked at alternatives to increase gas production through waste pre-treatment and post-treatment. We looked at the Pondus process and Lisk refeed. And we did determine that we were able to increase the gas production by about 25 to 30%. But this limitation with the billing rates and the diminishing returns after 7% energy neutrality actually created us that really reduced the value of additional biogas after a certain point. And so, and this also had the same impact on the fats, oils, and grease and co-digestion. So there was definitely a pretty strong relationship there between the electric utility billing rate and the overall biosolid strategy. So there's a pretty interesting link there.
Hey, Brian, this is
Yes.
Anthony. Sorry to interrupt, but we're, if you can close it up here in the next minute or so, we're getting
Yep.
tight on
Oh,
time. So
absolutely.
I apologize for that.
That is no problem at all.
Thanks.
So at the end of the day, what we found is that we're going to move forward with combined heat and power. And we were going to change our strategy if hauling costs reached a certain point. And when we were about mid-design through our first phase, hauling cost, and this was right when COVID-19 hit, and hauling costs increased a lot faster than we expected. So we had to stop and reassess the combined heat and power and our overall bioenergy recovery strategy. And what we found was that if we went with a smaller engine, we are actually could make a better financial case. We use the energy model to do that. And because with sludge drying, with the increased hauling costs, we now had a strong case for sludge drying, and that also could serve as an alternative outlet for the biogas. So that changed, having that flexibility, it changed our roadmap a little bit, but I think we're definitely now on the right path. But it really goes against conventional thinking. The smaller CHP unit actually made more sense than the larger CHP unit in this case. So just to wrap things up, there are a lot of evolving regulations, market technologies, really driving that need for integrated biosolids and energy planning. Having that level of, a dynamic and flexible plan that really helps us navigate these changing conditions, and, trying to make these plans as interactive using dashboards and other tools is really going to provide a lot of value in the future. So that's everything I've got.
Thanks, Brian. Yeah.
Pass it on to.
We're going to go back to Josh now, and we'll make all these slides available. I'll put it in a PDF so you can have everyone's contact information. I know we just have a lot of information to cover, so I know it's a lot for everyone. So just bear with us. All right,
Yeah.
Josh, you're up.
So can you hear me? That's my first question.
I can hear you.
Awesome.
All right, buddy.
Right.
Thanks, Josh.
Yeah, and hey, thanks, Brian. That was a lot packed into that. And I picked up on several. I'm really glad you went first, because I think there's some concepts in there that I was going to struggle to explain, and you kind of hit on it. So good. I think we're in a good spot. But I really did appreciate, I got to say, a lot of those visual decision tools that you've incorporated into your planning process. It just seems there's a lot in there. So I'm going to talk about, and thanks, Sustainability and Biosolids Committee for inviting me. I'm Josh Newman, and you already heard my bio, but I'm the Biogas Utilization Program Manager at the City of Portland's BES, Bureau of Environmental Services. And what I'm really going to focus in on, so while that last presentation, was very broad, I'm going to narrow it down to a piece of rulemaking that's falling in a single, fuels program. So I've also got a lot packed in here. I'm going to talk really fast. Sorry about that in advance. And now it's not advancing my slide. I'm plagued with issues here. So I wonder if there is oh, there it goes. So a big picture, I'm going to cover environmental credits for biogas, and then I'm going to really focus in on the renewable fuel standard, and then further drill into this proposed rule, which is EPA's proposed 2022 set rule and other changes. I think the rule is technically called 2023, 2024, and 2025 standards, RFS standards, and other changes. But within that, there are three main elements that I think are particularly germane to wastewater plants and water resource recovery facilities. And then I'm going to summarize what I think are kind of the key outcomes for water resource recovery facilities. So I wanted to talk about just broadly credits that are available. And as Bryan kind of indicated, I'm focused on the transportation fuel sector. So he went through some of the many end uses that you can apply biogas to, but I'm really focused on just the transportation fuel and primarily the RFS. So I'm including these state programs for context, but you should know that if you are producing RNG or electricity with your biogas, you may be able to participate in one or two of these credit programs and stack them. So with the state programs, which is California LCFS, the Oregon Clean Fuel Program, and the Washington Clean Fuel Standard, those are the three panels here on the right. Those programs are very similar to one another. I'm not going to get into a whole lot of detail. And you can partake of credits depending on where the fuel is used. So if you have a fleet that uses your RNG in California, then you can qualify for the LCFS credit, and that's stackable with the Renewable Fuel Standard, which is the national fuel program. So the Renewable Fuel Standard is administered by US EPA. The goal is to reduce our dependence on imported oil, and metrics really involve the feedstock, which is used to determine what category of biofuel that you're producing. RINs, and Bryan talked about this, a RIN is a renewable identification number, but it's a unique number that accompanies, that is attached to each quantum of fuel. In this case, a quantum of fuel is equivalent to a ethanol gallon. So it's 77,000 BTUs. And we can talk about that more later. The RVO is across the contiguous United States. It is the renewable volume obligation that obligated parties must purchase credits or blend in order to meet the demand for these credits. And it's volume based. So it's basically a volume of renewable fuel that is determined to be produced in these various categories. And then the D codes for the credits, that relates back to the feedstock. So the feedstock determines what category of biofuel you are ending up generating. D3s are what we, and D5s are what we can usually get with biogas. And the D3 is the most valuable. It's the cellulosic biofuels credit. D5 would be a advanced biofuels credit. And then the state programs, they're not volume based. They're just basically, the goals are to reduce GHG emissions, and they're based on CE2 metric tons of CO2 equivalents. I'll take questions on that later because I know I'm going to run into a time problem. So now I'm going to even focus more on the renewable fuel standard, just a little bit of history established back into, or at least the foundation of it established back in 2005 with the Energy Policy Act, and then expanded to include and define the RFS in the Energy Independence and Security Act, or ESA, in 2007. It's administered by US EPA, and in the statute that Congress called for, they envisioned an increasing domestic production of renewable fuels beginning in 2008 at 9 billion gallons total. And then that was kind of the watershed year, and then ascending up to 36 billion gallons in 2022. And it has a chart that charts out annually what the anticipated volumes nationally of each of these categories of renewable fuels should be. And then another important watershed moment was in 2014, the EPA issued a rule change called the Renewable Fuel Pathways 2 rule. And that is what qualified wastewater anaerobic digester gas to qualify for a cellulosic biofuel and eligible for those high value D3 RINs. And then similarly, that language in 2014, the rule change qualified electricity. So biopower from cogeneration facilities at wastewater plants to also qualify for D3 RINs. It just didn't provide any guidance. It didn't provide the program specifics, and that EPA just never got around to it. And so we've been asking politely for that to be done for a decade and a half now. And finally, in this new set of rules, they're attempting to do that. And then on the right, there's a chart that just it illustrates the nested nature of how these volume obligations work for an obligated party. So basically the cellulosic D3 volume, so they have to purchase or blend to a level where they can offset that obligation. And that counts towards their advanced biofuels obligation, as well as the total renewable fuels obligation. So that's how they're nested. The same with the D4 and the D5. And then everything in between advanced biofuels and total is achieved through purchase of these D6, which is ethanol credits. I borrowed these plots from the Renewable Fuels Association because it illustrates what Congress had in mind on the left there with their annual volumes of domestically produced biofuels, ascending up from like 9,000 up to, 9 billion up to 36 billion gallons per year. And you can see that the largest increase of that is in the advanced biofuels area, but more specifically the cellulosic biofuels component. And that is the space that that wastewater biogas is situated to play in. On the right, unfortunately, is the reality of what's actually occurred over the same period of time. And as you can see, every year since its inception, EPA has had to go in and lower those volume obligations to meet the supply available. And so when they set these renewable volume obligations, they're setting the demand for credits. That's what they're doing. So every year they've had to, unfortunately, lower those. And that's what causes the volatility in those prices. So if they lower them too much, then you have oversupply. And if you don't lower them enough, the cost of the credits spike. So there's a little bit of a balancing act there. So now I'm really going to focus in on the 2022 proposed set rule and the other changes. And the three areas, as I mentioned before, the electric pathway. So that is eRINs. That is something that has been, we've been asking for a decade and a half, and it's finally here. The set rule is basically setting the renewable volume obligations for each year following 2022, and that's where the statutory language ends. So there's provisions in the law that direct the EPA to then post 2022 begin to establish those renewable volume obligations. So this rule does that. And it also has developed an apportionment methodology for co-digesting cellulosic and non-cellulosic food or non-cellulosic feedstocks, which non-cellulosic feedstocks would be things like food waste and fog. So I'm going to start with the ERIN with the ERIN program, and it's based on this ERIN value chain that EPA considered in the rulemaking. So these are the players along that value chain that were discussed in the rule, the proposed rule: the biogas producer, the power producer, charging infrastructure owner, the electric vehicle owner. And then oddly, they added the automaker, or the original equipment maker as they're termed, into this. And it's odd because there's no other pathway in the whole of the RFS that operates this way, where a entity that never has ownership or takes ownership of the fuel itself is designated as the RIN generator. And so that's a key difference or divergence away from past practice that is being proposed here. So the set rule, so this is the timeline for basically for the set rule, but also the ERIN program timeline. And the set rule will, according to, if everything works according to plan in EPA's world, gets finalized in June of 2023. And there's actually a consent decree that was issued from a settlement agreement that that basically directs DEQ to have, or not DEQ, EPA to have that finalized in June of 2023. Then 60 days later in August, EPA begins processing ERIN applications. And then finally in January of 2024, that's when ERIN generation would begin. So I'm going to do this at the end of each. I'm going to go through some pros and cons. So in the biogas advocacy world, you know, where the experts are talking policy day in and day out, these are some of the pros that we're hearing about and the cons that we're hearing about. And so it's a big win, starting with the pros. It is a huge win for wastewater and other biogas entities, because it establishes this pathway to begin to leverage the RFS if you have a cogeneration facility. It adds substantial volume to the 2024 and 2025 cellulosic renewable volume obligations. It accommodates, it's flexible so that it can accommodate both power that's generated from raw biogas, and also if you've already built an RNG facility, you can at some point pivot to, you know, from just RNG to powering a generator with your RNG and as an intermediary for ERINs. And, you know, market flexibility is important. Designation of the OEMs as RIN generator does, I mean, they have a good argument for why that streamlines the process. There's a smaller number of EPA applications for them to go through. It lowers the documentation burden on all of the players along that supply chain. And then importantly, it replaces the old RIN conversion value of 22.6 kilowatt hours per RIN to 6.5 kilowatt hours per RIN, which more than triples the overall value of the biogas. Just basically triples the number of RINs that you're going to be able to generate, all told. The cons are, many in our industry are really pushing back on this idea of OEMs as the RIN generator. Mostly it's inequitable. I mean, it really places the majority of the financial risk accruing to the biogas and the power producing industries or sector. OEMs really don't operate in this space, so they're new, and for that reason, you know, this is kind of referred to as the Tesla rule, because apparently Elon Musk was pretty involved in negotiating this outcome with EPA. It also is a substantial departure from established practice, as I mentioned earlier. And then things like the line losses, the efficiency losses along that transmission line, and then at the dispenser are really accrue to the power generator. So that's inequitable. And then it requires that your cogen facility be using 100% biogas, no natural gas allowed. So that might disqualify certain cogeneration facilities, where at wastewater plants, you sometimes have to rely on natural gas as a backup fuel. So those are some of the cons. And now I'm going to move on to the 2023, 2024, and 2025 RVOs. There's a lot in this slide. I'm focused primarily on the cellulosic. So the D3 portion, I should say that you can also generate D5 or non-cellulosic with if you're co-digesting. But for reasons I won't go into now, I'm choosing not to talk about that. We can talk about it in questions. And I'm also going to kind of wave my hands at this first line, which is liquid cellulosic biofuels, because it's negligible. So the two main components of the proposed RVOs for the 3 years are really based on the projected RNG RINs and the projected E-RINs. And so for the RNG RIN portion, EPA compared the years 2021 and 2022 and found that a year-over-year growth rate of 13.1%. And then they applied that to 2023, 2024, and 2025. And so that's why you see that line increasing over those years at a steady rate of 13.1. For the E-RIN portion, that starts in 2024, and it's based loosely on the EV passenger car fleet that exists now and the projected growth in sales of EV passenger vehicles. But EPA determined that for the 3-year period under consideration, that the E-RIN volume would be limited primarily on the capacity of third-party engineering firms to register qualifying generation facilities, and not the potential supply of biopower. And as we get past that 3-year period, it's going to flip where EV sales will increase to the point where biopower supply will be the primary limiting factor. So pros and cons here. Again, pros, it's increased revenue certainty over the next 3 years. And so that's huge because, as Bryan pointed out, volatility is a major hurdle for many decision makers to invest in this type of a scenario. It increases the cellulosic RVOs with both the RNG, which they call the CNG, LNG portion, and the E-RIN portion. The cons are there is a sizable fear among biogas advocates that the RNG part is being grossly underestimated and could lead to oversupply and price crash. And the reason for that, they say, is that EPA used these 2 COVID years and they completely dismissed the impacts that COVID had on delays to projects. So we could get a glut of projects that were COVID delayed in 2024. It ignores the stimulatory impacts of the Inflation Reduction Act funding on projects. And for those reasons, industry leaders are really thinking that the real rate of increase in supply is going to be more 20 to 30 instead of the 13.1%. So we're really relying on EPA to have the flexibility built into this rule to be able to come in midstream and address oversupply with like an intermediate RVO setting rule that they would do in year 1 or year 2.
Hey, Josh,
So
just let you know, 5 minutes.
Okay, cool.
Okay, buddy. All right, thanks.
This is basically, I'm wrapping up here. I have a couple of slides left, but this is kind of the main event really, which is the proposed RIN apportionment method, which really allows for municipalities to consider doing co-digestion, because currently EPA has considered that if you put any amount of non-cellulosic feedstock into your digester, it will consider the entire digester contents non-cellulosic. So you basically kind of devalue all of your credit potential from a D3 to a D5 in that scenario. What this apportionment method, which has been lobbied for year after year for the last 10 years, is to do a proportionality between the feedstocks, and they've come up with a pretty good scheme for doing that. It's conservative, but it does allow us to say, hey, we have data, we can show that our municipal sludge per pound of volatile solids destroyed is going to give us X number of cubic feet of gas. Let's say it's 15 cubic feet of gas for every pound of volatile solids destroyed in the digester. If you don't have that data, in other words, if you're not collecting that data, and maybe this is a smaller utility or maybe it's an ag digester that they just don't have the flow meters in place and they're not monitoring, they allow you to use a default value from the literature, and then they'll cut it in half. So let's say it was 15 cubic feet, standard cubic feet per pound. They would say, well, it's 7.5, and that's what your D3 RINs would be, and everything else would be D5s. So those are the two options. So the pros are on the surface, hey, it's a rational approach. It's the one we've been asking for co-processing cellulosic and non-cellulosic feedstocks. It's going to have and as such, it'll have a favorable impact on return on investment, the business case for investing in these co-digestion improvements and organic waste receiving facilities and such. The con is really boils down to that value of 50% discount if you don't have the data. So that's where I think the pushback is coming. That's way too conservative to take a haircut of that size. And I think folks are thinking it's probably 10%, maybe 20% would be acceptable. So possible outcomes for water resource recovery facilities are definitely big gains, new revenue opportunities, especially for biopower and cogen facilities for the eRIN program. Definitely big gain, reduced financial risk and increased financial incentive to invest in high strength waste co-digestion. But a little bit of trepidation about the way that they're estimating the RNG portion of the cellulosic biofuels obligation and the specter of a possible oversupply, really kind of driving home the need for EPA to step in mid-period and readjust those RVOs. And so we're looking for those provisions in the new rule when it comes out. And with that, I will hand it over to our next speaker.
Thank you, Josh. So our next speaker is going to be Mark, and he's going to actually be talking about renewable natural gas, biogas to natural gas pipeline. So this is a project that they recently started up and is in commissioning at MWMC. Marcus is a civil engineer there with MWMC and the City of Springfield Environmental Service Division. He serves as a project manager for them, overseeing capital projects, including this one that he's going to talk about today, related to renewable natural gas. Prior to working with the city, he worked at Los Alamos National Labs as an environmental engineer. He has a BS, MS in civil water resources engineering, and also an MBA from the University of Mexico. Go for it, Mark. Thanks for being patient, buddy.
Yeah, no problem.
Okay.
Can everyone hear me?
Yes.
Good deal. Well, thanks for asking me to present today at this PNCWA conference, Anthony. Wanted to talk first and say, now that everyone's got the policies that have been discussed over the last hour all memorized and detailed out, I'm going to go into a little bit of the experiences that we've kind of gone through over the past several years with the development of our renewable natural gas project here at Metropolitan Wastewater Management Commission, which is really a combination of the cities of Eugene, the city of Springfield, and Lane County. There are actually a number of people on the meeting today that have a large role in the production of this project, different parts of the state. Josh actually, I think, was one of the first people leading this project, and I kind of took it over into construction. But I want to talk to you a little bit about where we started and kind of the process that we went through and kind of where we're at now in terms of production, revenue generation, and some of the challenges and lessons learned that we've learned along the way. Sometimes I think we take ourselves a little seriously, and so I like to add a little humor in the beginning of my presentations. So I've actually got this little joke that I saw like almost 2 years ago. it says with the gas prices out of sight, Santa uses alternative fuel sources. And so he's got all of his different reindeer eating beans, and you've got gassy, Tudor, and stinker. And it's a little bit of what we're doing, right? We're taking biogas and we're processing it into renewable natural gas for injection into the grid. So the project actually started a long time ago. We've been running a combined heat power generator at the water pollution control facility that we have here in Eugene since the 80s, but we were only able to utilize about 60% of our biogas. And the commission really has a focus on resource recovery. And they said, look, how can we better utilize all of our gas? Is it to add another CHP? Is it to build a renewable natural gas facility? And so we went through that process. Josh and Kennedy Jenks and others went through that process and ultimately went through a triple bottom line and came to the conclusion that really the best path forward is for us to enter into an agreement with Northwest Natural, process our biogas into renewable natural gas and feed it into the grid. So starting about, let's see, this was late 2019, early 2020. We actually had pre-purchased RNG equipment and we were ready to go into construction. And we bid this project outside as kind of COVID hit. But we built it over the year of 2020, 2021. And we were able to actually first start injecting renewable natural gas into the Northwest Natural grid in November of 2021. So, like I said before, there are a number of people in this project that kind of helped from a team standpoint. We had MWMC, which really includes the two cities, but in that piece, our operations group, our maintenance group, and others have really been helpful, kind of getting the capital project through the construction and up and operating. But others, such as Kennedy Jenks, was our design consultant on this project. This is actually their rendering back from the completion of the design. We've got ongoing agreements with Northwest Natural to go ahead and feed into their natural gas grid. DSL Builders helped us build this. Green Lane was the equipment supplier. And provided, I'll talk to you a little bit more about the technology, but the pressure swing adsorption technology that ultimately we utilized on the system. And then we're doing our credit sales with, used to be Blue Source, now it's Anew. So that's actually who's wheeling those credits that Josh was talking about, the RINs for the federal renewable fuels standards, as well as for the low carbon fuel standards when we do sell into California. So this was the rendering that was done at the completion of the design. So we're looking at winter of 2020, right before we started construction. And ultimately, actually, the plant looks relatively similar to this. So you've got the two large hydrogen sulfide removal tanks on the south side of that brick building. Most of the compressors that power the equipment that takes that, very simply, that 60% methane, 40% CO2, and scrubs out the CO2 and sends the other contaminants to the thermal oxidizer that sits over to the left before sending the product gas back into the natural gas grid. So this is just a real high level of the process. We have a feed gas blower that takes the gas from our flare, and essentially it bypasses the flare and it comes into the system. It gets pressurized just enough to go through the hydrogen sulfide removal system, which is mostly made up of, it's actually a combination now. We've got axe trap and sulfatreat, but it removes the hydrogen sulfide from about 1,300 parts per million down to, we're hoping, less than 10 as it goes into the pressure swing absorption system. It gets compressed, goes through a 12 tank pressure swing absorption system where mostly that CO2 comes off, but also trace amounts of nitrogen, oxygen, some siloxanes and VOCs are removed and sent to the thermal oxidizer. Then that methane at that point in time, it's really pretty much 99% methane, gets boosted to line pressure, which in our case is about 140 PSI. So this is the process flow diagram. It's a bit of an eye chart, but it shows kind of the start of the project at our flares. And it kind of shows the raw gas blower in line, and then the 2 hydrogen sulfide removal tanks. We boost the pressure going into the pressure swing adsorption system. The waste coming out of that process, which is the CO2 and VOCs, goes to the thermal oxidizer in the upper right-hand corner. Then we get boosted, the pressure gets boosted, and it goes into the grid at that point in time. So a little bit about pressure swing adsorption system, because when we started this process, our plant toured a number of facilities in our region, mostly in California, actually, to look at what kind of technologies would be best for us to construct and then ultimately to operate. And we ultimately settled on an air liquide membrane system that we wanted to go with, that I think was being operated down in California. However, when we got into the procurement process, it was not as easy to do as we originally kind of were hoping. And ultimately we went, because we weren't able to go directly to air liquide, and that procurement process kind of got hung up, we ended up going back out and asking for the different equipment suppliers to provide what they thought was the best system for our current situation. And ultimately we awarded a pressure swing adsorption system award to Green Lane to go ahead and pre-purchase the equipment prior to getting the general contractor on site. So I mean, ultimately the system that they provided and designed takes the biogas in, and ultimately the media within the pressure swing adsorption system has a different affinity of, the media has a different affinity for the methane and the CO2 depending on what the pressure is within the tank as it goes through and rotates through the different tanks. So when it gets pressurized, it allows the CO2, or sorry, the CO2 binds to the media, whereas the methane can flow through. And then when the vacuum gets pulled, that media gets regenerated by taking the CO2 and the VOCs off of the media and taking it off to the thermal oxidizer. So that is a little bit about technically what our project is doing. We've been up and running for a little over a year now. But what our commission is interested in both are the environmental benefits of this, as well as the financial benefits, which there's been a lot of talk kind of leading up to this in this meeting. And I think Josh hit on a lot of these, but I'm just going to touch on them briefly. You know, we're selling 3 main things, which is the physical gas, which is commodity, the federal renewable fuel standards, which are RINs, and then the low carbon fuel standards, which is, I mean, for the most of our case, it's into California. Oregon has a program and Washington has a program, and likely those programs will grow and maybe we'll be able to sell into those in the future. But currently most of the sales have been into California. The rates for both the RINs as well as the LCFS credits have dropped quite a bit in the last year. I think a lot of that is due to kind of this new set rule that Josh is talking about. But I mean, we started, I think, originally selling at $3.70 a RIN, and we're down to about $1.93 the last sales we saw. So we've got ongoing contracts on the revenue side, and then we've also got ongoing operations contracts or maintenance contracts with, in particular, Green Lane to help us support some of the operations of the equipment, although that's a pretty minor piece. The biggest ongoing financial piece probably is power and is the change out of the hydrogen sulfide media. But you can see we're selling our natural gas, our brown gas, directly to Northwest Natural. And then we're selling our credits to Anew. So they actually work as the intermediary with the different refineries and registering the credits for us as they sell. So this is a little bit of our overall operating summary since we started operating in November of 2021. We didn't get a whole lot of gas injected in November and December of 21. So really starting in 22, we were producing gas. And through February, so we've got March now in there, but we had produced a little over 72,000 MMBTUs or decatherms of gas, which is a little less than I think we were anticipating. Most of that has to do with uptime. We've had some months where we're at 98% uptime, and some months where we're 6% uptime, and that has a lot to do with lessons learned. Trying to time and manage things like media replacement on the hydrogen sulfide tanks. We've had issues with the regenerative thermal oxidizer methane slipping through and being too high to get into the RTO. But with that 72,000 decatherms, we've realized about $300,000 in brown gas revenue from Northwest Natural. A little over 1.5 million in our renewable fuel credit sales. That's really where the bulk of the revenue is. And it looks like it's probably going to be that way for a little while, but I could be wrong. Low carbon fuel standards, we've sold a little bit, about 30,000 to date. And the O&M costs, the trick here for us is the actual straight O&M costs are not this high, but there is an offset since we do have CHP, so we have to offset the power that we would have produced there, as well as the fact that now you have to also run a boiler to go ahead and heat the digesters. So there's kind of a trade-off in terms, and those costs are real, and so we've kind of tried to capture that there as well. So, our commission keeps asking kind of what the payback is, and it keeps changing, and it depends a lot on what happens with the different credits. But roughly, we're looking at about a 9.5-year payback at about 1.5 million in revenue a year. That's given our final capital cost of about 14.2 million. It's important to note that projects have a way of increasing in cost as they go, and ours did. Some of that is inevitable. We try as best we can to kind of lay things out and work through them, but especially with escalation and things going on, the costs definitely have been going up. So, like I said here, payback is highly dependent on federal renewable fuel standards. And then you can see, 80% of the revenue that we're expecting really is coming from the federal renewable fuels standards program. So that RIN value changes by $1 and, we get $11 different in 1 decatherm of gas we produce. So that's a pretty big multiplier. So, I touched on this in the beginning, but I think it's important for utilities to understand this isn't a 1-year kind of process. Like you say, hey, I think this is great. They need to understand that the process takes time, and there is a learning process even once you're through the design and through the construction and through the startup. And so you can see, Josh started this back in the biogas study phase when we were looking at, do we want to go with another CHP or maybe we want to fuel our own fleet. We went through a triple bottom line. We worked with Trillium for a while to take our gas. That ultimately didn't work out. We hired Kennedy Jenks to help us through the process. We had to sign an interconnection agreement with Northwest Natural. And, if you're a gas utility, we've talked to a number of other agencies within Colorado and Washington, and, they all have to deal with their own gas provider. Pick the type of technology you want to go with, pre-purchase. Ultimately, in our case, we were hoping to benefit from time. And then construct it and start it up and deal with some of those things. I think everyone keeps looking for the perfect technology to do this, whether it be water wash, a unison membrane system, or a PSA, or an amine system. I mean, ultimately, from everyone I've talked to, each one comes with its own pluses and minuses, and it's kind of a matter of picking what works best for your facility, and it's a bit of a challenge.
Hey, Mark, just 4 minutes left, buddy.
Yeah, no problem.
Okay,
I'm almost
thanks.
done
Okay.
here.
All right, thanks.
Resource recovery, I touched on. I mean, this is really why we were doing this. Was our facility is very interested, or our commission is very interested in resource recovery, and RNG or CHP was a big part of that. So lessons learned, keep telling our commission, look, it wasn't only about finances. It was about the environmental driver first and foremost, and financial second. Strong and balanced partnerships. I think sometimes when you get in with another large utility, such as a natural gas utility, sometimes a balanced partnership is difficult to work through. Safety concerns, wastewater treatment plants, they're used to dealing with biogas, but not always pure methane that's pressurized. Need to focus on that. Focusing operator to help with the startup was a huge thing for us, and Spencer has been a huge asset for our facility. Integrating flares in the digestion operation. Gas meters, calibration of meters is huge. Realistic expectations, the thing isn't going to just start up and run continuously. Integration of the thermal oxidizer if you do have tail gas. And I've got this one down here, and I'm not sure that I wouldn't have pre-purchased the process equipment if I had it to do again. That being said, I think that what we did was right, given the what we knew at the time, especially given that COVID overlaid it, because I think we lost a lot of the benefit that we maybe would have received from the pre-purchasing of the equipment by then having to construct during COVID and having the equipment get hung up overseas because of manufacturing issues. And I don't know how you would have seen that coming. So I think that's it. This is Lorenzo with Northwest Natural actually turning the valve and letting our RNG flow into the Northwest Natural grid down here in Eugene. I've got my final slide is questions, but I will leave that to Anthony to field at the end.
Thanks a lot, Mark. This is really good stuff. It'd be great lessons learned, and be interested talking to you more about that at a later time. Thanks, Mark. So our final presenter is going to be Derya, and she's going to be talking about her recent work on technology and processes for pre-treatment and management of source separated organics. Derya is Hazen and Sawyer's West Biosolids Practice Lead. She received a PhD on conditioning and dewatering of biosolids. She has over 15 years of planning, process design experience in biosolids and bioenergy. Prior to joining Hazen, she was an associate professor and involved in several research projects on biosolids management. Currently, she's involved in biosolids and energy master plans, technology evaluations, and optimization studies. She has over 50 publications in conferences and peer-reviewed journals. And she recently just completed the SSO pre-treatment project, which she'll be talking about today, and currently is active in 3 research projects with the Water Research Federation. Derya?
Thanks, Anthony, and thank you to PNCWA and all of you also sticking around. I know it's not easy to listen. Thanks for almost 2 hours right now. So I appreciate your time. So we will actually switch the gears a little bit. We have been talking about the gas part of it and talking about bioenergy in the last couple of presentations. I will take you back a little bit to the organics piece of the equation. As Anthony mentioned, this is going to be mainly our presentation on our recent project that we have completed for Water Research Foundation. So the co-digestion has been sort of a hot topic in the last decade, starting with early 2000s. Actually, we have started seeing interest in this area, and there have been evolving regulations around co-digestion. I put this sort of little quote, that came from Water Environment Research Foundation at that time. Really there was a push in the last decade to look at digesters, anaerobic digesters, as an outlet for different organic components. So again, as part of this push, we have started working with the Water Research Foundation around 2019-2020 timeline, which we have completed our project 2022. So I'm going to spend pretty minimal time on introduction. We have already touched base with Riley's presentation on co-digestion and why you need to consider. Obviously, organics means energy. It has high energy content. You can bump up your biogas production that we just talked about what to do with this biogas. It has a lot of economic value, the tipping fees also, and also the savings. But another component that I need to mention, that most of the facilities already have the infrastructure. There have been a lot of studies in different states that we are looking at to evaluate the excess capacity in anaerobic digesters, and a lot of the studies are showing 30–50% actually excess capacity in different states. So there is a capacity already built in our treatment plants, resource recovery facilities, and we already have sort of everything set in terms of process and technology, in terms of having our digesters in place as well. And again, we have spent significant amount of time talking about the greenhouse gas reduction and lowering our carbon footprint as well. This is very well established. Again, we touched base on rules and regulations across the country. What I want to actually point out here is we are seeing sometimes statewide bans or laws, but we are also seeing in certain states that is sort of difficult to push the things on statewide level. The cities are also taking initiative as well. There are a lot of cities and states that are already implementing those rules and regulations, but we are also aware of a lot of other local agencies and states also evaluating as we move along. Again, for this specific study, what is considered as source separated organics? Again, the term and terminology sometimes could be a little bit confusing. So for this study we have conducted, this includes not only food waste, it includes a little bit beyond food waste. And when even we say food waste, we have to consider pre and post-consumer food waste. So it's not just the material that we send to our landfills. There is also actually food waste that is before consumption that is considered as well. Some animal waste from rendering facilities, industries was also considered. Agricultural waste produced from poultry farms, slaughterhouses was also included. The waste produced from school cafeterias or commercial kitchens, restaurants are also included. And again, the residential source separated organics, the material that we separate in our home with different bins, also considered as well. What is not included in this project was the yard waste, wood waste, and paper waste. This is not really included in our project. So first thing, we need to accept that not all organic waste is the same. There are a lot of differences when we look at all different organic groups. And we can consider the biosolids, sewage sludge. We can consider manure as an organic waste. Again, industrial sources, animal processing from industrial sources, restaurants, cafeterias, grocery stores, residential. They all have different characteristics. And as you move along sort of that arrow down, you are going to see that there is going to be an increase in solid content. So this is more liquid stream, more like pumpable form most of the time. And as you move along, you see more solid waste characteristics. And you also observe a decrease in homogeneity. So these sources could be more homogeneous and sort of well mixed and balanced. as opposed to the residential SSO could be very unhomogeneous product. And also the contamination level also differs significantly along those sources. So the main objective was our project was really providing water reclamation facilities a guidance and tool to develop and manage their own co-digestion program. Again, we didn't focus on the impact of co-digestion on anaerobic digestion or overall wastewater treatment facilities. Really, what we have been trying to establish here is, okay, what are the technologies currently available to take the source separated organics and make it a pumpable form so that you can feed it directly to your anaerobic digesters, and what you need to consider, and what are the management strategies that you can also adopt. So those are the things that this project mainly focused on. We had in our project, we developed four different tasks, and they were sort of completing each other. The first task was looking at the literature. A lot of information is available all around the globe, although food waste co-digestion or organics co-digestion is relatively new for us. There are a lot of countries that have been practicing food waste co-digestion or specific just food waste digester itself. So we have looked at those. We have also conducted a lot of surveys. We send the facilities that are already practicing co-digestion survey forms to capture their treatment technologies for the organics. And then in task 3, we actually deep dived and sort of funneled down those case studies to get some cost information, to get some more specific O&M information from them. So task 3 was way more detailed in terms of application of those in real world. And in the last task, we have developed sort of the guidance tool for the facilities to select the treatment technology or unit processes. So the first task really started with the global literature review that shows sort of all the facilities around the globe that we have looked at. As you see, there have been a lot of facilities that we covered in Europe. We looked at papers, we looked at reports, we looked at manufacturers' information, conference proceedings, hundreds and hundreds of material reviewed at that time. So what has been identified was sort of, if you need to sort of group your pretreatment process in buckets. So the first process that's very clearly identified was the separation processes. Those are what we call unit operation processes. And separation was a big group. There are different types of screens. There are rock grid traps to separate inorganics from your source separated organics. There are even also sorting sort of tables or hand picking also applied in different places as well. So there is a big separation technologies group per se. And there are also size reduction technologies that have been widely applied for that. Shredding and grinding are the main ones. Those are sometimes necessary to be able to process those organics and be able to pump them into your digesters. And then another group of processes that are identified really aims to make a homogeneous mixture. As I mentioned, depending on the source of the organics, some of them could be really readily available, homogenized already, but some of them may require those additional processes. And popping, mixing, blending are some of those technologies that are identified. This is a brief sort of a summary table that shows sort of the non-organic components that we generally would like to separate when we are trying to extract organics, and also sort of those unit processes, which one will be actually applicable, or which one will work best to be able to separate those different components from your system. At the end of our literature review, we have sort of tried to develop a process flow diagram, if you want to say it, for source separated organics. This is a little bit of a challenging, because as I noted, The characteristics of SSO could differ significantly. But what has become pretty obvious is there are generally some initial processes, like if the material comes in bags, there's a bag opener, or you need to separate certain things like inorganics, like rack trap, rib trap, or trommel screens to open up the things. There is always a core process. Sometimes it's a hydropulper, sometimes it's called the packing process, sometimes it's called extrusion. There are different names depending on the manufacturer. And at the end, sometimes it's necessary to put a polishing unit. We have seen a mixer, a hydrocyclone, or a slurry tank is also found beneficial in most of the facilities. So again, the technologies could slightly change, or the name of the technologies, but really those are the main steps for source separated organics. What we have also realized is you could do source separated organics treatment in different ways. You could have like unit processes on your site, put back to back each other, like how East Bay Mud is currently practicing. They have built their own processes as they move along. But there are also package systems, hybrid systems that are available from different manufacturers that you can buy like a box, and you can push one end your organic source, and then the other end it comes like as a slurry, and then you have the waste component. So there are also systems that allows you to do that. It's a preference, and then sometimes things evolve as you move along and change. But those are the two main groups that we have identified. For different processes, also we have identified a lot of different technology providers all around the world. So that was the first task. And as we move into task 2, looking at things a little bit in detail, we really reached out 17 utilities, again, in Europe and in Canada, in the United States. We prepared questionnaires asking them more specific about the equipment that they have, and what are the source of their organics and their machines, what they like, what was their motivation. So I put here just the facilities from North America as a reference. If again, we have developed some fact sheets for each facility. So you can see we have a lot of facilities from California. We have 2 facilities from Pennsylvania and 2 facilities from East Coast, New York and New Jersey. And we also have 2 facilities from Canada as well. What was also obvious for us was how those sort of treatment was handled in different areas. Some water reclamation facilities prefers to perform all of these in their fence line. They like to control everything. They like to have this pre-treatment on site. Some have a third party that collects this material and conduct some pre-treatment and brings a pre-treated waste source into the facilities. And the facility has a couple of things like a mixing tank to store all these, or sometimes a rock trap and a mixing tank. So, but main portion of blending and homogenizing could be handled in another place. And some of them really doesn't want to deal with any of those. They don't want to deal with the solid waste that's very complicated. So they have a third party that does everything for us. They just get everything in a pumpable form, and then they just pump it to their digesters. So that's also another model that was observed. And we have also realized there are standalone pretreatment and digestion facilities. Those are not really integrated with any water reclamation facility. Those are more regional facilities that takes all around the organics and just has their own digestion process. There was also a couple of different facilities that only prefers to take pre-consumer waste. And some of them we realized would like to take post-consumer waste. So there have been also some differences in there as well. So those are the sort of the fact sheets that we have developed for all these 17 studies that we have looked into in detail. As you can see, we have looked at the source of the organics, dairy, frozen vegetables, condiments, for this specific Hermitage facility, what do they have as a process? They have a depacker from Veolia, they have SCAT equipment. So all this information. We have also put some insights about the units that and the processes that they use, and also some lessons learned a little bit for each fact sheet as well as all the information about the facilities. The next task was getting a little bit more deep diving into those facilities and learning more information about mainly the cost and O&M side of things, because those were the two areas that people were really trying to get more information when they are trying to decide, how to manage their SSO source. So we have identified 6 utilities for that. Those are the ones that specifically selected that has successful application for source separated organics pretreatment. East Baymont was one of those. The other one was Disco Roads from Toronto. Central Marine Hermitage and 2 facilities from Europe was also identified. Again, in this task, we did a detailed mass balance analysis for each facility. We gathered O&M information, how much they are spending for treatment of those organics. We have looked at construction, operating, maintenance costs, also additional revenue that they generated from the extra biogas, along with the tipping fees, and also how much they spent to dispose the inert material and contaminants from their sources. What was very obvious, obviously we don't have time to get into all these details, but the values were very variable. There have been significant variance, order of magnitude. It was very difficult to come up with like even a range of cost for that. The final task was basically providing a guideline for the utilities that are looking at organics pretreatment and taking organics into their facilities. Really, we have developed different sort of flow schematics depending on contaminant type, size, and characteristics. So a couple of sort of lessons learned and what we heard: identify sources as well as possible and characterize them really well. I guess the lesson that we would like to convey as a result of those. All the results are available in our report that's available by Water Research Foundation, and we also develop dashboards that's interactive that you can go and look at all the fact sheets, all the results from all the case studies, as well as all the literature review conclusions that we have. Very final quick lesson learned before I wrap up. From all this sort of communications with these facilities and a lot of literature review, pre-treatment is really crucial. Really, you can take directly organics and accept it in your facilities. Grit and inorganics removal is the most critical piece that you have to make sure you take this away before you do anything else, and remove some of the other inorganics metals as much as possible, glass metals, those that we have looked in the table that I presented. Sometimes receiving a pre-treated slurry really streamline operations, and it might be operator friendly if you don't have this bandwidth with O&M staff, because you are going to need more staff to handle those organics. Again, understanding your feedstock is important. You need to have sufficient capacity and storage in your facility. You also need to think about truck loading capacity and truck loading area, because this might bring a lot of traffic in your fence line as well. So you need to take this into account, never underestimate that, I guess. Maintaining of equipment is very crucial. Again, dealing with organics and solid waste is not the cleanest thing, and maintenance is very crucial. Having critical parts on site as things breaks down is also important, especially during COVID times where supply was a big problem. Always have multiple critical parts for these processes on site. And also sometimes putting a specification if you are accepting from third party or others, just make sure you identify what you are accepting as an organics. And if you have a pH solids % or different parameters that you are establishing, make sure that those materials are meeting those specifications. Overall, on the financial side, although those organics bump up gas production significantly, majority of the facilities that is applying co-digestion, the main driver for them seems to be the tipping fees. It's a source for income. There's a financial drive, and generally the financials are favorable for tipping fees rather than the biogas portion at this point. So with that, we have the barcode here. If you would like to see the final report with a lot of details, and also our dashboards, everything is available. So feel free to visit, and hopefully you will find the information useful. This was the project really that has been conducted with different researchers from Manhattan College. We have a great project advisory committee. We also have a lot of utility partners, as you see, as we have been developing this study. And I have a lot of also co-workers that has helped me through as we wrap up our project. So with that, I think that's all.
Thank you, Derya. So we're about I don't know, 13 minutes over. So I just open it up to questions, and we'll give you guys the full 15 minutes. I know I'll hang around, and I'm sure some of our other presenters will hang around. So with that, we'll open it up to questions. You can unmute yourself. I would just ask maybe just raise your hand so we can kind of go through that. And that's under the reactions. A little happy face. So let me see. Matt, did you have a question? Matt? Any questions?
Actually, I have one for Josh. Josh, have you seen any evidence in the set rule that's going to also allow utilities to offset purchase power, gain that benefit, as well as create renewable, or as well as profit from E-RINs? Kind of double stacking there.
Yeah, I think from what I understand, there is, like, if you're talking about renewable energy certificates, like power purchase agreements with those renewable power. So the offset itself, I believe that that you're able to offset your own power usage just as you would otherwise. So that's my belief. I think it would behoove people to check that themselves. And then the other thing, of course, is we don't know because it's still a proposed rule. So anything can happen between now and then. But the talk that I've heard, and it's like a 600-page document. So and I think the E-RIN section was huge. So it was a couple hundred pages anyway. But I do believe that it does allow you to offset your own electricity. So you don't have to sell the electricity, you unbundle the credits, and those environmental attributes have value separately.
I was going to share my screen real quick if folks don't know how to raise their hand, or let me see here. Where did that So if you look, let me see. It went away.
You could also use the chat box for questions.
Yeah, but you're unable to mute yourselves. So just feel free to jump in and I'll stop sharing. Unless there aren't any questions.
You know, I think the audience is in shock at
Oh,
the
okay.
amount and the pure volume of fascinating information that came their way. So we might just want to let them recover.
Oh, let me see. Okay. Yeah, let me go ahead. Sorry guys, I'm not used to this Zoom stuff. So
Anthony, I believe there's a question in the chat box from Medi Lieberman for Mark, and I can read it.
yeah, I can. Let me see if I can unmute her. Yeah, you can read it if you want.
Has there been any effect on the partnership with NW Natural from the natural gas ban in new homes in Eugene? Do you expect that relationship to change with the pending rule?
Yeah, I mean, that's a question that we've gotten a lot of. And there's kind of a, piece, the city of Eugene, for those that don't know, put in an ordinance to ban new natural gas in new, I think it's like single family homes moving forward, but it's being potentially re-challenged. Ultimately the project never would have entered into that space because we're putting it into the system, and so Northwest Natural might not have as much demand as they originally had thought, but they still have plenty of demand and they're still trying to green their product. So so the short answer is not a lot. There's been a lot of questions around it, but no direct impact.
And you should be able to unmute yourselves now. I think there was some option to do that.
Okay, there is a question estimating the amount quality of those. I think I can try to answer this question. So really the amount of SSO is generally dictated by your available capacity in the facilities. That's generally the limiting factor, the amount. Really that's the one that's dictating us because if you need to build a new capacity just for SSO, that's not sometimes easy to make the financials work, or return of investment is not there. Again, if you have funding sources or in some incentives that might be easier, but generally the capacity dictates the amount of SSO that's going to be accepted. Quality of SSO, again, it's up to you what you want to accept to the facility. A lot of facilities just prefers liquid stream like sugar water from brewery that easily bumps up the gas production. That takes a lot of capacity in hydraulic capacity. Some of them likes pre-consumed material, like Hermitage loves pre-consumed material. They take it from supermarket, grocery stores. So really, in terms of the quality, again, it depends on your infrastructure most of the time. So for SSO, was PFAS evaluation? No, the PFAS was not measured in those. And again, really, we didn't characterize the material by ourselves by taking samples. It was more information gathering, but PFAS was not a criteria that was looked into.
All right, there's a quiz, so you guys got to ask questions.
Yeah.
There you go. There you go, Eddie. Come on, buddy.
Yep. No, it was informative, buddy.
All right, good, good. Any questions?
Definitely not.
No, okay. And
I,
we'll
I
try
can
to,
keep up. I can keep up with what you guys are talking about.
all right, good. And what I'll do is I'll get in touch with Marie too. So I'll try to get, I'm gonna get all the presentations together, do the PDF and send it out to
Right
the
on.
folks attending, and we'll have people's contact information. Go ahead, Josh, your hand up. Josh Newman. Are you just high-fiving? All right. All right, well, if no one has any questions, well, I appreciate you guys taking the time. I know it's a lot of information. You know, you plan these things and you think, 2 hours is plenty, but before you know it, I mean, it's, you know, it's over. And hopefully no one fell asleep, so. All right.
Right on. Well, thank you guys.
All right, thanks. All right, everyone have a great day, all right? Thanks to the presenters too, appreciate it. Great job, awesome, good information. And then don't forget, when you close this out, they'll pop up a window to get your CEU, so make sure you get that, take advantage of that. And your PhDs, or PhDs, professional credit hours. All right, guys, thanks a lot.
Thank you.
All right, take care. Bye.